Okay, YouTube, we're at it again, solving trig equations in which we have more than one type of trig function involved. So a little bit more complex than just isolating a common trig function or factoring for a common trig function. We have more than one trig function and we need to know how to deal with such a situation. So in previous videos, we were able to use trig substitutions such as wherever we saw a tangent, we could rewrite it as, say, sine over cosine, or like a secant is 1 over cosine. And also if we had squared trig functions, we could use Pythagorean substitutions. In this instance, you'll notice that we have sines and cosines, so sine x minus cosine of x equals 1. And so neither of those are squared, which means we can't use a Pythagorean substitution. And neither of these are reciprocal trig functions, so we can't necessarily list them as reciprocals, or at least not in a convenient fashion. So here's going to be our method. We are going to try to invoke, all right, this is a really interesting word, to call forth, but invoke the Pythagorean identities. And recall the Pythagorean identities spawned from this sine squared plus cosine squared of an angle equal 1, which basically implied also that then sine squared is equal to 1 minus cosine squared, as well as cosine squared is equal to 1 minus sine squared. So in order to get these to work for us quite well, what we're going to do is we're going to take one of these trig functions, and most conveniently it's the cosine here because it is negative currently, but we're going to kick it to the other side of this equation so that we get one trig function on one side and the other trig function on the other side, so 1 plus cosine of x. And then our method is going to be this. We're just going to take both sides of this equation and square both sides. So on the left here we get sine squared of x, and so that's where our trig substitution with our Pythagorean is going to come into play. But the right side, keep in mind that squared means times itself. So we have to take 1 plus cosine times 1 plus cosine, or times itself. So let's go ahead and FOIL out the right hand side here. We get 1 plus cosine x, so plus 2 of these cosines of x, and then we say plus cosine squared of x. So now this is all equal to sine squared of x. But the nice thing about this is now sine squared of x, we can substitute in this trig identity from the right here. That's equal to 1 minus cosine squared of x. So now we have 1 minus cosine squared of x, and this is equal to 1 plus 2 cosine of x plus cosine squared x. So now this is all in terms of cosine, this equation. So what we want to do is, since it's quadratic, that is we have squared cosines as well as cosines to the first, we're going to go ahead and try to factor this, which means we'll want to set this equal to 0. So let's go ahead and clear the entire left side here. That is, we'll subtract 1 and we'll add cosine squared of x. And this is actually a really good, convenient example, because when I subtract 1 here and I add a cosine squared of x, you're going to see this. First of all, we get our left side to drop out. And so our left side is just 0. And on the right side, you'll notice you get your constants to drop out. Now, this is just the problem I used. It's not always the case that your constant drops out, but what you get left with is essentially this. We say, okay, so using our commutative property of addition here, I'm going to switch these around. So I've got cosine squared of x, 2 cosine squared of x from these two right here. And that's plus 2 cosine of x. This is very factorable. As a matter of fact, the greatest common factor between everything on the right, solving this by factoring, is 2 cosine of x. So we're going to factor out a 2 cosine of x, and what's left is this. We get just cosine of x, and that's plus 1. And this can be easily checked by redistributing this and seeing that we get the primary expression back here. So now we've got something that says, well, hey, this times this equals 0, therefore either 2 cosine of x equals 0, or cosine of x plus 1 equals 0. So in this first instance, we'll go ahead and divide everything by 2, and so we get cosine of x equals 0. And in the second instance, we go ahead and subtract 1 from both sides, minus 1 minus 1. And so we get cosine of x is negative 1. So now what this implies is, let's go ahead and stash these up here. We end up with x then is cosine inverse of 0. We also have x is cosine inverse of negative 1. So now checking out our unit circle, we say, okay, so what angles would give us a cosine value of 0? And so we obtain those angles by looking at x values. So we'd say, well, up here at pi halves and down here at 3 pi halves, we got a cosine value of 0. So we'd say, well, then x is pi halves and 3 pi halves. And as far as cosine inverse being -1 goes, we'd say, well, that occurs at pi radians, okay? An x value -1, so at pi radians. We say is pi. And so, yeah, there's our solution. So recall that when you have just, say, a sine and a cosine, the best tact to take is to kick one of the trig functions to the other side, let's square both sides, and then we can use a Pythagorean substitution as we've seen in prior videos.